In this lesson, we will cover questions from section 3.6, polynomials of the form ax squared plus bx plus c. Question 1. Factor 3x squared plus 14x, subtract 5 completely. When we want to factor a trinomial of this form, we always check to see if we can remove the greatest common factor first. And if we notice we have 3x squared plus 14x subtract 5, there is no greatest common factor for those terms. So we're just going to go ahead and use the decomposition model. So we're just going to take our a term and our c term and multiply, and that gives us negative 15. A product of negative 15 and a sum of 14 will give us 1 and 15 with a negative 1. You rewrite your a term to be 3a squared, taking the highest factor first. And then we're going to take our second factor, which is negative 1x. So you can write negative 1x or just leave it as negative x. And subtract 5. So all we're doing so far is rewriting the 14x into our two factors that we found to give us the product and a sum that was required. Now we're going to remove the greatest common factor, which is going to be 3x, which leaves us with x plus 5. In order to get the brackets to be the same, we're going to have to remove a negative 1 here, which will give us x plus 5, the same as the other bracket, and that's what we need. So if you see these brackets are the same, you need to go back and look through your factors again. So our two factors now, our two binomials, is going to be 3x subtract 1 and x plus 5. So our answer here is actually going to be B. And if you wanted to go back and verify your solution, you can take the two binomials, use the distributive property to see if you will receive the trinomial back that's in the question here. Question 2, factor 6x squared plus 27x plus 12 using the rectangle model. There's a couple of ways you can approach this. You can use the rectangle model right away, or you can check to see if you can remove the greatest common factor first. And removing the greatest common factor always simplifies your expression, so that is a little easier to work with. And we're going to do that first. And if you notice, you can actually remove a positive 3 from all three terms, which will leave us with 2x squared plus 9x plus 4. So all we need to do now is just look at this expression here, this trinomial. So we're going to use our box method. We're just going to draw a box on the side. And in our box method, we're going to have to place our terms. So we can right away put our a term here, or x squared term, and we're going to put our c term on the bottom. But how do we actually find the two factors for 9? So what we have to think of is similar to what we've done previously. We take our 9 on the top. Actually, we're going to take our 8. We're going to go 4 times 2. That's our c and our a value. So you go 2 times 4, which gives us 8. And we have to find two integers that multiplies to give us 8 and gives us a sum of 9. So easy enough, it's going to be 1 and 8. They add to give you 9 and multiply to give you 8. So you're going to take your highest and you're going to put it up to the top, right hand corner, and your lowest and you're going to put it down on the bottom here. So now we have to use this to factor. So coming from this column, we're going to see what is the greatest common factor we can remove. And it's actually going to be 2x. From here, what is the greatest common factor we can remove? And it's only going to be 1. Now, from this row, from 2x squared and x, we can only take it in x. And then from 8x and 4, we can only remove a 2. So our greatest common factors are all removed from each row and each column. We're going to go back now and write down our brackets, our binomials, which will be 2x plus 1 and x plus 2. So don't forget now, we already took out a GCF of 3, so that has to go in the front of your two binomials. If you actually distribute everything out here and use the correct multiplying steps, you will realize that This here will multiply to give you back the original trinomial, or you can substitute a number in for x to see if the left-hand side equals the right-hand side.